Welcome into the VPN lab, and in this lab we're going to build a very simple GRE tunnel between two hosts in a simple network that I've set up in GNS3. Now the files for this GNS3 topology are available as part of the work files for this section of the course, and the base configuration is laid down on all of these routers. Here in the middle I have the router of mystery, and the router of mystery is our internet router, if you will. The whole purpose of the router of mystery is to basically break routing between the remote and the HQ networks. The HQ and the remote both have a default route pointing at the router of mystery. However, the router of mystery only knows about its directly connected networks, so while I can ping the remote from the HQ and ping HQ from remote, I can't go from remote host to HQ host. However, because I like to prove I've got nothing up my sleeve, let's go over here to HQ, and we will ping the remote router, which is 40.50.60.254. So we will do ping 40.50.60.254, and we have complete success going from HQ to remote. However, if we go over here on the HQ host and try to ping the remote host, it will fail. Now the remote host is 192.168.1.1. So we'll go over here on HQ host and ping 192.168.1.1. And of course, all of these will fail because the router of mystery, while it knows about both of these networks up here, it does not have a route to either of the LAN networks, either on the HQ or the remote side. So the traffic comes through the HQ router up to the router of mystery and simply dies there because the router of mystery doesn't know how to get to 192.168.1.1. So as I mentioned, we're going to configure a GRE tunnel between these two so that it acts exactly like a WAN connection directly from the HQ router to the remote router, and we'll use tunnel interfaces to accomplish that. For the tunnel interfaces to work, we have to have a network that is specific to those tunnel interfaces. In this case, we'll use 70.80.90.0. I'll make HQ.1 and remote.2 just to keep things simple. So let's go over here on the HQ router, and we'll do config T, and we're going to configure a special type of interface called a tunnel interface, as I mentioned. A tunnel interface is almost exactly like a loopback interface. It's a virtual interface, doesn't really exist, but you can treat it as if it were a real honest-to-goodness interface. So we'll do interface tunnel, and we have to give the interface a number, just like with fast Ethernet or gigabit Ethernet or serial, so on and so forth. We can give the interface a number between 0 and 2.1 billion. I really wouldn't recommend having 2.1 billion tunnel interfaces on a single router, but if you're really crazy, I suppose you could do that. However, for our lab, we'll just choose tunnel interface 0, and you'll see there are no other options. And since the router knows that we're going to configure tunnel 0, it brings the interface up and the line protocol is down because there's nothing plugged into the other end of this interface. And obviously, since this is a virtual interface, we won't have anything to physically plug in, but we will configure what device is on the other end of the tunnel. So we'll hit enter. And we're now in interface configuration mode. There's all of the interface configuration options that you'd have just as if you were configuring a serial or an Ethernet or whatever you'd want to configure on this router. So we'll go ahead and give this guy a description of tunnel to remote. We'll go ahead and give it an IP address of 70.80.90.1 with a Class C subnet mask. However, there are two different commands that we have to configure on this tunnel interface because, again, it is a tunnel. In this case, we'll do tunnel, and the two that we're going to configure are source and destination. So we'll start with the source. The source is kind of confusing for people that have never set up VPN tunnels before. This is the interface where the traffic will leave, not necessarily where the traffic is coming from, because again, there could be 50 networks behind this one router, but they will hit this router and they'll go out a specific interface, and that's going to be the traffic that we're going to tunnel through this interface. Now for the source keyword, we can either give it an IP address or we can use an actual interface name. And again, the interface name is good if this happens to be on a connection where you have a DHCP client running on your router, so your IP address may change. In this case, since it's in a lab, I'm going to actually use HQ's WAN address pointing at router of mystery of 10.20.30.254. So we'll do 10.20.30.254. And there are no other options for the source. And the tunnel destination is where are we going to send the tunneled traffic. In this case, we're sending it to the WAN interface on remote, which is 40.50.60.254. So we'll do tunnel destination, and all you have the option for here is a host name or an IP address, since obviously you don't know what kind of interface is on the other end. So we'll do 40.50.60.254. And once we configure the destination, the line protocol comes up because, again, it's trying to communicate with the destination on the other end. We'll pick this up in the next video where we configure the remote end of the GRE tunnel and we set up EIGRP to exchange routes through the tunnel. So welcome back to our GRE lab. In this lab, we have already configured the HQ end of the tunnel interface. So let's go to the remote and configure the other end so that the tunnel actually comes up. So on the remote end, we'll do config T, interface tunnel 0. And just like on the other end, the line protocol is down because we haven't finished configuring it yet. So we'll go ahead and give this a description of tunnel to HQ. We'll give it an IP address of 70.80.90.2. So IP address 70.80.90.2 with a class C subnet mask. We'll also do tunnel source, and we'll use the IP address connected to the router of mystery, 40.50.60.254, 40.50.60.254, and we'll do tunnel destination of 10.20.30.254. Once we do that, the line protocol should come up. And again, since this is an interface as far as this remote and HQ router is concerned, I can actually do show interface tunnel 0. You notice that the encapsulation is tunnel instead of being serial or Ethernet or anything like that. And you'll notice that on our tunnel, we did not set a key. So this traffic is not actually encrypted. It's just tunneled through the router of mystery, or i.e. the internet, so that the two networks appear to be directly connected. So if this works, I should be able to ping 70.80.90.1 from this router. So if I do ping 70.80.90.1, I have 100% success because now I can go through the tunnel. In fact, if I do show interface tunnel 0, we now see that we've sent 5 packets and received 5 packets because, again, it's just like any other interface. However, we're not done yet, because even though this tunnel interface does exist between the two sites, I still can't ping HQ from remote. If I go here and do ping 192.168.1.1, again, I don't know the route, so I'm just following my default routes, and it still ends up right at the router of mystery and dies at that point. So as kind of a proof of concept, let's set up EIGRP across the GRE tunnel that we've just established. Now, on HQ and remote, I've already set up EIGRP to advertise the LAN networks on both sides of the connection. So it's already advertising 192.168.1.0 and 172.16.2.0. However, since we now have this tunnel interface, we have to add the tunnel network to the EIGRP configuration, at which point these two routers should become neighbors and should start exchanging routes and should allow me to ping all the way from HQ to remote. So let's do that. And again, we've already gone over EIGRP configuration, so I'm just going to kind of blow through this. Config T, router EIGRP 4199. We're going to do network 70.80.90.0 with a class C wildcard mask. And we'll do the same thing over on remote. Config T, router EIGRP 4199. Network 70.80.90.0.0.0.255. And here in just a moment, the two routers should become neighbors and start exchanging routes. There we are. We now have a neighbor adjacency on tunnel 0. It's up. And if I do show IP route on this guy, it is now learning about the 192.168.1.0 through the tunnel interface. So now I should be able to go to my HQ host and ping through that tunnel. And of course, the first one will time out because of ARP, but we have success. And if I ping again, we have 100% success. And the interesting thing is, if I do a trace route from this guy to 192.168.1.1, you won't see me go through the 10, 20, 30, or the 40, 50, 60 networks. You'll see me go through 70, 80, 90 to get there because I'm not taking this route. I'm taking this virtual tunnel that's directly connecting the two. So if I do trace route to that guy, you'll see 172.16.20.254, which is my default route here. You'll see 70.80.90.2, which is the remote tunnel interface, and then you'll see the actual host itself, this router over here at remote host. So hopefully, if you're like me, actually setting up a tunnel, a VPN tunnel, even though it's not encrypting or authenticating, will kind of cement some of the concepts in place. And of course, GRE tunneling is one of the requirements for the exam, so we've covered that as well. And that concludes our section on VPNs.